So in this video, we will see a combination of universal law of gravity and circular motion. Okay, how can you associate universal law of gravity with circular motion? So for example, we have a planet. Okay, we have a planet in the middle with mass m, and we have a satellite with mass lowercase m. Okay, so the red dot. And the satellite is orbiting around in a circular pattern around the planet at a distance r. Okay, so at a distance r. So a typical question would be, how fast should the satellite travel? So how fast? What is the velocity? Okay, velocity of the satellite. Okay, velocity of the satellite. V of satellite to stay in orbit. To be able to stay in orbit. To stay in orbit. Okay, orbit. The V of the satellite in order to stay in orbit. Okay, so let us begin by applying the force of gravity, which is Fg equals G m and m, which is the product of mass divided by the square of the distance r, F of g. Okay, so F of g. Now the velocity that we're trying to figure out here is the tangential velocity. Okay, so the tangential velocity v of the satellite. So how do you figure out this v? Now let's get back to a lesson on circular motion. So we can say that the net force is equivalent to the mass multiplied by the acceleration, Newton's second law of motion. But since the object is moving around in circles, we're going to change the acceleration into centripetal acceleration. In our case, the centripetal acceleration is going towards the center. So this will be our centripetal acceleration. So now we can change this into the net force equals the mass of the satellite. Since we're talking about this satellite that is going around in orbit, multiplied by the centripetal acceleration. Now if we look at the different forces acting between the planet with mass m, and the satellite with lowercase m mass, there's only one force that's acting along it, and that is the force of gravity. If there's no force of gravity, therefore the satellite will go off its orbit. It's going to be in a straight line because according to Newton's first law, an object in motion will remain in motion, or it's going to travel in a straight line unless acted upon by unbalanced force. In our case, there is an unbalanced force since the net force is not going to be zero because of the presence of force of gravity. So therefore we can say that that is mass times centripetal acceleration. But from former videos, okay, from previous videos that we have, that is AC is equivalent to the square of the velocity of the orbiting object, which is m, okay, divided by the radius r. So that will be our AC. Now let's start plugging in the values, which is Fg equals m multiplied by the velocity squared over r. Velocity square over r. But also from the first equation we have Fg is as follows. So let's plug in this value of Fg right here. So what I'm going to do, I'm going to change the color of my pen so you can see it. So instead of writing Fg, now I will have G m multiplied by the lowercase m, which is the mass of the satellite, divided by the distance square, and that is equivalent to mass velocity squared over r. So right away we notice that if I divide both sides by m, I can cancel my m. I'm talking about the mass of the satellite. And then since r, if I move it to the other side, I will cancel one of the r's and my r right here. So therefore I can say that G, m, and m over r is equivalent to v squared. But I'm not solving for v squared. I want to figure out the value of the velocity. So therefore, we must take the square root of both sides of the equation, giving us the velocity is equivalent to g, the square root of, or we can say velocity square, or velocity. I got confused, since that is v, and that will give us the square root of g, and there's no more m because it's already canceled. Okay, so there's no more m. That was my fault. So there's no more m. So all's left is the uppercase M over R. So this will be our equation to solve for the minimum velocity in order for it to stay in orbit. So what will happen if our velocity is less than this velocity? What will happen is that the effect of force of gravity will takes place, and our satellite will be sucked in by the planet because of the universal law of gravity. Universal law of gravity states that two objects tend to attract each other, and that's a universal law. And how much does it attract? It all depends on the masses, which is the product of the masses and inversely proportional to the square of the distance. So this will be our minimum velocity. If it's greater than the velocity, then what will happen? If our velocity is greater than this value, what will happen is it will be thrown away, because the unbalanced force is definitely greater. One thing that I also miss is that why is it that it's positive instead of negative force of gravity? Because the direction of force of gravity is towards the planet, so you have the same direction as your centripetal acceleration, so that's why your force of gravity is positive. Please reach out if you have any question about this video. I'll be happy to answer your questions. Thank you.